Hey all, this is Junaid again. Welcome to this new knowledge punch video. In the previous video, we learned about the inverse proportion. That is, x and y are two variables that are inversely proportional to each other, then the product will always be a constant, say k. And we solved the question using the equation method too. Now in this video, we will learn a shortcut to solve the same question as promised. We can apply this shortcut if two objects are inversely proportional to each other. Since its product is constant, we call this rule as product constant rule. In order to solve this question using the shortcut, we have to know two rules, two simple rules. The first rule states that if two objects are inversely proportional to each other, if one object increases by a rate of a by b, then the other object decreases by a rate of a by a plus b. The second rule states that if one object decreases by a rate of a by b, then the other object will increase by a rate of a by b minus b. Let's check this rule before we solve our actual question. For example, let's consider 20 and 40 as a length and breadth of a rectangle. And we all know how to find the area of the rectangle, isn't it? So the formula is basically length into breadth to find the area of a rectangle. Substituting the values of length and breadth in the formula, we will get the area as 20 into 40, which is 800. Now to check the rule, let's keep this area constant for a moment and let's see if the length is 10, then at what rate breadth increases. Since length initially was 20, now has decreased to 10, there is a 50% decrease in the length. That is, the length has been decreased by 50%, which is nothing but 1 by 2. As per the rule, if one object decreases by a rate of a by b, then the other object will increase by a rate of a by b minus b. So here, length decreases by a rate of 1 by 2, then the breadth should increase by a rate of 1 by 2 minus 1, which is equivalent to 1. Thus, the breadth increases by a factor of 1. So the new breadth will be the original breadth plus the increase, that is 40 plus 1 into 40, which is 8. That is it. The area of a rectangle remains constant as 10 into 8 is equivalent to 8. Let's solve our question using the rule, right? Our actual question which we started off with. Let's check out the question. You see here in the question, the product is constant, isn't it? Yes, the product is constant because if we read the question carefully, it is giving two different speeds and correspondingly two different times for the constant distance. And we know that the speed and time are inversely proportional to each other. If you notice the speed in the first scenario, it was 5 miles per hour, and the second scenario, it is 7.5 miles per hour. But the speed has increased by 50%, which is 1 by 2. Now what did we learn about the first rule? If the speed increases by 1 by 2, then the time will decrease by, that is a by a plus b, which is nothing but 1 by 3, since the distance is constant here. In the first scenario, at a speed of 5 miles per hour, he took 20 minutes more than the actual time to reach his destination. And the second scenario, at a speed of 7.5 miles per hour, he took 12 minutes less than the actual time to reach his destination. So the difference between the time, let's say T1 and T2 will be equivalent to 32 minutes. 20 minutes plus and the 12 minutes early. 20 and 12, 32 minutes. We have to convert this 32 minutes into hours. Why? Because every value in the question is given as miles per hour. So we have to divide this value by 60. So 1/3 of T1 is equivalent to 32 minutes. Solving this equation again will give us T1 will be equivalent to 32 by 20. Now if you substitute this in the distance formula, that is where we know the speed is 5 miles and the time taken corresponding to that speed will be 32 by 20. Simply multiplying this, we will get the answer as 8 miles. That's it. We didn't create any equation. This D and T is just for the reference here, right? So easy, isn't it? If you know this rule, we can just find the answer in few seconds. I hope with this understanding, you can solve a similar problem. Catch you in another interesting video. Until then, stay tuned. This is Junaid signing off.